right, so recording now. So let's kind of do some code in C, and then we can try to convert that to MIPS using these two instructions, and then I'll show you some kind of slides, and then we can talk about again the third instruction. So I'm going to start with something very kind of basic. I'm going to say int, a equals to 5, int b equals to 10, and I'm going to say if a is equal to b. That's how you do it in C. If that's the case, then I'm gonna make I'm gonna say a equals to 100, and that's it. And then and I'm gonna say a equals to a plus 5. Okay. So if you were to run this one, first let's make sure that we understand the logic of this one. If you were to run this one, what would the value of a be? Can someone tell me? 10. Okay, that's good. Exactly. Because a is not equal to b, I'm going to skip all of that and I'm going to add 5 to 5. I'm going to put 10 in a. Now, you know what I'm going to ask you next, right? Which is, let's convert that to MIPS. And here, I'm going to give you some instructions. So I'm going to say use register, say is0 for a, and register is1 for b. All right. So who wants to try to translate this to MIPS? We can start with these two lines, and then we can think about this one. So how do we do these two? How do we give 5 to A and 10 to B? Okay, so we do need to use add immediate. So that's right. Okay, so this is right. So I'm going to say add immediate is 0, 0, 5, and then add immediate is 1, 0, 10. We don't want to forget the comma. Okay. Now, what do you think about this one? Can someone, give me kind of the right direction? Okay, so let's see. So Catherine is saying maybe we can have a line and give it the label L1 and then do add, which is really, okay, so you want to do this one. Okay, add immediate is 0, 0, 100. Okay. Okay. All right. I'm gonna just go along and see. So of course, this is not complete, because if you were to execute this one, we're gonna run this, we're gonna run this, we're gonna run this, and that's not really what you want. So there has to be a branch on equal or branch on not equal. There has to be. Whenever you have an if statement, you're gonna have to have that. Now the question is, which one do you want to use and how do you want to use it? So think about that. I know this is not the easiest question, but I do want to give you a few seconds to think about this one. Think about this one. I'm going to give you a few seconds. Okay. So Catherine is saying, how about we do branch on equal, and if S0 is equal to S1, essentially if A is equal to B, then I'm going to go to L1. And L1 is going to be this one. Okay, so that's good. I mean, I'm not very happy with what you proposed, Catherine, but it's okay. We can try to inspect it and see what the problem is here. How about this line? What's going to happen to this line? We probably should have this line at some point, right? Maybe at the end. Let me have it at the end. I'm going to say add immediate S0, S0, 5. Okay, so Katie's saying we can have this one, which is this one, after L1, which is really what we want. Now, can someone tell me what's wrong with what we have here? Let's try to trace it in the two scenarios. So one chance would be, one possibility would be A is equal to B, and the other possibility would be A is not equal to B. Now, when A is equal to B, I'd like to execute this one, and I'd like to execute this one, because this one executes regardless. So let's see. Branch on equal, if S0 is equal to S1, I'm going to go to L1. So this is good so far, because if S0 is equal to S1, I'm going to go to L1, and I'm going to execute this one, which is really the if statement body, and then I'm going to execute this one. So this is good, actually. When A is equal to B, this code is going to run as expected. Now, I think you probably are guessing what I'm about to say next. And that is, when A is not equal to B, we're going to have a problem here. And let's do that in C first. When A is not equal to B, I'd like to skip this portion. I'd like to skip the if body and go to the after the if. But let's see what happens in the MIPS code. Let's say S0 is not equal to S1. What would happen if S0 is not equal to S1? What do I do? Can someone remind me? So when they're equal, I'm going to go to L1. But what happens when they're not equal? You still execute L1 because you go sequentially. All right. So here, if the content of register A is not, let's actually go to this one. If the content of A is equal to the content of register B, then we're going to jump branch to L1. I should have said if the content of course I did say it, but I didn't write it. If the content of register A is not equal to the content of register B, then we go sequentially. So of course, in this case, this code has a problem, has a flaw. In fact, the fact that you have L1 right after the branch on equal makes this code, this line, kind of useless. This line doesn't do anything, because if they're equal, I'm going to go to L1, which happens to be the next line. And if they're not equal, guess what? I'm going to go to the next line. So this line is doing nothing. So you don't want to have this code. This code clearly has a flaw. So Grace is proposing another piece of code. So here's what I'm going to do. I'm going to strike all of this, and I'm going to listen to Grace this time. Now, of course, I'm really happy that Catherine, you gave me this, because this is a very good attempt. It's not quite there, but this was a really good attempt. And this is really how we learn. I mean, we start with something, we find kind of a problem in it, and then we try to fix it. Okay, so Grace is saying, let's keep the first two lines. I agree. I don't know why I did this. I'm going to keep the first two lines. And let me actually just, you don't need to see this one. I'm going to copy the new suggestion. So the new suggestion is here. So let's see what's going to happen. So notice here that instead of using branch on equal, we're using branch on not equal, which is really a good idea. So here what we're saying is if S0 is not equal to S1, so if A is not equal to B, then I'm going to skip the F body. And that's exactly what we have here. So if this one, if A is not equal to B, then I'm going to skip the F body. So I'm going to skip this one and I'm going to go to L1, which is really exactly what I want. Now, of course, when this one is equal to this one, then that's going to make branch not equal false, because essentially that's going to make me not branch to L1, because I'm going to only branch to L1 if they're not equal. So if they are equal, because that's if they're not equal, they have to be equal. So if they are equal, I'm going to go sequentially and I'm going to execute this one, which is really the if statement body, and then I'm going to execute this one anyway. Let me pause here. I want you to look at it and make sure that this kind of makes sense. Does that make sense? Okay. So typically, when you see an if statement that has, equal sign, what you want to do is you don't want to use branch on equal. I mean, it seems that branch on equal makes sense because this is kind of equal, but really what you want to do is you want to use the opposite. You want to use branch on not equal. And if you see a condition that contains not equal to, so something like if A is not equal to B, that's how you do it in C, in the language C. If A is not equal to B, then when you translate that to MIPS, you want to use branch on equal. So that's kind of just something to keep in mind. Okay. Now I'm going to introduce another instruction, and then I'm going to give you another example where we would have to use that instruction. In fact, I'm going to ask you a tough question. I'm going to ask you to convert an if else without the instruction that that I was going to introduce. And this is actually okay. You can still write code using what we learned to translate what I'm about to write in C to MIPS. So here I'm going to say, let's say int A. I'm going to actually copy all of that. I'm going to paste it. I'm going to post some slides with kind of more organized code, but sometimes I like it like this, kind of free form, because that'll allow us to pivot if we need to. That'll allow me to copy your suggestions and paste them. So what I want to do here is I want to do else. Let me kind of do this. And this else is going to say, for example, B equals to, let's say A equals to 50. And I'm just going to keep this one. Sure, why not? I'll just keep this one. Okay, so this one, so because this is a single line, by the way, because the body of the if is a single line, and because the body of the else is a single line, I'm going to remove those curly braces. I can, because it's just a single line. That'll just save us some space. I do need the semicolon here. Okay. So do you want to think about that? Think about this for a few minutes. In fact, what I'm going to do is I'm going to copy what we did, because it's actually close to what we did. The correct answer is close to what we did. And let's kind of trace it really quickly. These two lines will be translated to these two lines. In case A is equal to B, let's just think of that case. If A is equal to B, then branch not equal is not going to jump to L1, right? Because Branch not equal will only jump if they're not equal. But in this case, they're equal. Right now, I'm assuming that they're equal. Of course, what that means is that, right? I mean, of course, if we have 10 in A and 10 in B, they're going to be equal. We're going to do 100 to A, and then we're going to add 5 to A. So let's do that. So we have 10, 10. They are equal. So I'm not going to go to L1. I'm going to go sequentially. And sequentially means this part, which is really assigning 100 to A. And then after that, I'm going to add 5, to A and put it in A. So in fact, if A is equal to B, the MIPS code runs correctly. Now, of course, if A is not equal to B, then there's going to be a problem based on what we have. Because if A is 5 and B is 10, so if they're not equal, then what's going to happen is that's not going to be equal. And because of that, we're going to branch to L1, because here we're saying if A is not equal to B, go to L1. So we will go to L1. However, in L1, we're going to only do this. What we should do is this and this, because that's what happens when A is not equal to B. Okay. So we have a suggestion by Grace, and I'm going to copy the code and paste it. So these two lines actually stay the same. In fact, this line also stays the same. And even this line stays the same. And I'm going to change this line. I'm going to replace it with kind of 3 lines. Okay. Okay, that does look kind of sophisticated. So hopefully it's correct. Let's kind of trace it. Let's try both cases. So let's say A is 10 and B is 10. So A is 10, so which means S0 is 10, and B is 10, which means S1 is 10. And of course, in this case, they're equal. I'm going to do this one, and then I'm going to do this one. Let's do in MIPS what happens. Let's see in MIPS what happens. Okay, I think, Grace, you're saying there's a problem here. Well, let's look at the code together and see what the problem is. If this one is not equal to this one, and this is actually not the case because they are equal. If they're not equal, I'm going to go to L1, but because they're equal, I'm going to go sequentially. So I'm going to do this one, which is actually good. So I'm going to do this one. So this one, I can actually change the color if you think this would help. Let me do it. Let me try it. So this one is going to be the same as this one. Oops. I think it's here. Yeah, so I did this one and I'm going to do this one. So that's good. And then here, what Grace is doing is essentially she would like to skip this. Well, that's, I'm not really sure right now what you're trying to do, but this is not right. I mean, I thought I knew, but this is really not the right way to do it. Okay. So let me swap this with that. So let me kind of do L2, L1, or let me just do L1, L2, and let me just jump to L2 here. Okay. No, this is not the here. Okay. Let me. Yeah, let's see what you were trying to do here. Yeah, I think I removed the line here by mistake. Let me add the line that you had here. Yeah, this is what you had. Now let me swap things around and then we can think about it together. I'm going to put kind of L1 here, L2 here. So essentially, it's the same order. So this one, really, which I can give a color of something like red, is really the same thing as this one. And of course, this one is going to be the same thing as this one. So if they're equal, I'm going to, go sequentially because I'm using branch not equal. And I'm going to execute this one, the yellow one, which is fine. And then what I need to do is I need to skip this else. This is really the important part. Is this red part, which is really the else, needs to be skipped if A is equal to B. So what I'd like to do is if I go sequentially, I'd like to do this, but after that, I'd like to skip L1. In this case, I called it L1. How can I skip L1? Well, maybe I should have some sort of branching here that's going to go to L2 regardless of the condition. So maybe what I was kind of hoping that you would, and I think you did a great job here because you're on the right path. But let me kind of change it so that it's correct. You need to do something that looks like this, maybe 0, 0. Or even S0 is 0, it's fine. It really doesn't matter. We can do S0 as 0. So in this case, when S0 is equal to S1, I'm going to say branch if it's not equal. Well, they are equal, so I'm not going to branch. I'm going to go sequentially. So I do the F body, which is this yellow. And then this line is going to make me skip the else. Why is that? Because S0 is obviously equal to S0. They're the same register. And because of that, I'm going to go to L2. And going to L2 is going to mean skipping this else. Let me pause here and see if you have any questions. Does that make sense? Think about this for a few seconds and let me know if you have any questions. All right. So this, you see this here? This can be replaced with another instruction. Uh, Actually, let me see. There is a question here. Let me read the question first. Do we ever use L1? Uh, like you mean, do we ever execute L1? Yeah, we do execute it when they're not equal because and I know that you know right now, but just to kind of tell everyone else who's watching this video because that's a good question. Remember that when S0 is not equal to S1, we're going to go to L1. So we're going to skip this. We're going to skip these two. So this is really the F body, and this is really the branch that's going to skip the else. And of course, going to L1 is going to go here. And then we're going to execute this one. So in this case, L1, a very good name for L1 is else. And this one would be after the loop. So these are better names than L1, L2. So if they're not equal, I want to go to the else. And of course, when I do the else, I'm going to do the after because I go sequentially. If they are equal, I'm going to go sequentially. And this is really the if body. I don't need a label here because I'm not jumping here. And after that, this particular line is going to skip the else. So this one essentially is like skip the else. All right, I think now you got it. And what I was gonna say is that we don't usually do this because this is called unconditional branch. Essentially, this condition here is really, in this case, it's kind of pointless to have because we just want to go to after, we just want to jump to after, we want to skip the else. And instead of doing this code, we can just say jump J, just J, which is really the jump. J is an instruction and it has this syntax, J and then label. And this one will simply jump to after. So this is what we should do when we want to jump unconditionally. All right. So this is great. I'm going to ask you another question. And then after that, we're going to stop the recording and we're going to talk about, I think we can talk about loops or we can talk about kind of inequalities. So something like if something is less than less than or equal to something. And I think it's better if we do that instead of doing loops. So let me do an example here and let's make sure that we understand all of this. And then I'm going to stop the recording and then I'm going to start a new recording and talk about how to use less than, again, greater than, less than or equal to. And we'll do more examples. And then maybe that's it. Maybe we won't have time to talk about loops, which is okay. We can do that tomorrow. So the example is, let's say, if S0 is not equal to S1. So notice here that I'm using C variables that look like registers. The reason why I want to do this is because I want to stop telling you this. I want to stop giving you this, like use register S0 for A and register S1 for B, because this is kind of additional information that you have to make sure that you're kind of remembering. And it would be better actually if I just say S0 and S1 and we know what those mean, right? S0 is going to be S0. So the variable S0, this is my way of telling you that the variable S0 needs to be stored in register S0. That's simply what it is. So here I'm going to say S0. In fact, I don't want to give S0 or S1 any values. So there's code here that you don't have to translate. I'm going to do this and I'm going to say, for example, S0 is equal to S0 plus 5. And then S1 equals to S1 plus 5. And then I'm going to have else. And I'm going to say S0 is equal to, S0 plus S1, just random stuff here. S1 equals to, S1 plus S1. And then here I'm going to say at the end S0 equals to, 200. Actually, no, that would be kind of silly to kind of reinitialize it. Let's say S0 plus 20 and S1 is equal to S1 plus 10. So I'm gonna so we're going to write the code here to the right of it because we don't have a lot of space. I'm going to actually do this. I'm going to change the font to my font, which is a font that I created, by the way. Not from scratch, but it's a combination of multiple fonts. Because some letters there are some letters that I didn't like, others that I liked. So I kind of started picking different, fonts for different letters and just put this font together. So I'm gonna, I'm gonna just wait for you to give me some ideas, and you don't have to give me the whole answer. You can tell me, you can give me a portion. You can give me the beginning of it. You don't even have to give me code. You can say, let's start by doing this. I'm going to give you a minute at least to think about this. Yeah, I'm going to just give you some time. So the question that Grace is asking, can we make two L1 lines? No. So you cannot have more than one line with the same label. But that maybe shouldn't be a problem because we kind of go sequentially. So I don't think it should be a problem. I mean, I know it shouldn't be a problem. But I don't think it you should think that it's going to be a problem. But I'll give you more time. Do you want time? How about you give me a reaction that indicates whether you're writing some code, because you might be writing code in the chat window. If you feel that you're not writing code, you want me, okay, so someone is writing code. Okay, let's wait. So I'm gonna pause the recording so that I think I can. Yeah, let me pause it and I'll resume it once we have the answer. All right. Um, so we do have an answer. So this answer is not correct. And that's why That's why I want to copy it and paste it, and then maybe, we can kind of help each other fix it. Um, so let me start by pasting the answer, and quickly we can detect that there's a problem. Um, so this, just by looking at these two lines, I know there's a problem. The reason why there's a problem is this particular line, again, is not doing anything, because if this one is not equal to this one, I'm going to go to F. But if this one is equal to this one, I'm going to go sequentially, and I'm going to end up at the F. So here, clearly, we have a problem, because this line, which is really part of the F body, is going to execute regardless. So there's another suggestion, and the suggestion is, instead of, but first let me, before I talk about the other suggestion by the other student, do we see the problem here? Do we see that there's a problem here? Just by looking at these two lines, we have a problem, because regardless of whether these two registers are equal or not, we're going to execute this one, and clearly we shouldn't, because this is part of the F body. This is part of the F body, and the F body may not execute if we go to the else. So give me thumbs up. I think you see a problem here. Okay. All right. So the other student is saying, maybe instead of saying branch on not equal, I can say branch on equal. But before that, I do want to say that I really like that, you used if and else. I really like this. Being descriptive like that is great. So the other students is saying, how about we do, if they're equal, then we go to the else. Actually, that's not really what the other student is doing. Yeah. In this case, let me copy what the other student did, and let me paste it, and let's kind of see what the problem is. So this is not too bad, but it has a problem. So let me show you another answer. Okay. So this is one answer, which I'm going to actually put in a new, this is the first answer. This one is the first answer, which again, we saw there's a problem in, but maybe overall it's not a bad answer. We can revisit it. I want to see the second answer by the second student. And this one is not quite right, because here what this code is saying, if S0 is equal to S1, I want to go to L1, and L1 is adding 5 to S0. Now this is kind of not correct, because if S0 is equal to S1, we go to the else. Because here, if they're not equal, I'm going to go here. Yeah, so, okay. Also, this particular code has many branches. 1, 2, 3. Okay, let's go back to the first answer. Maybe the first answer will be easier to fix. I like the first answer because at least it's using if and else. That I kind of like. I think the correct answer is a combination of the two. So I don't want to say that one of them is better than the other, but I do have to pick one and fix, and I'm going to just pick this one because it has kind of if and else here. Okay. So if they're equal, where do we want to go? If this one is equal to this one, where should we go? Where should we go if this one is equal to this one? Should we go to the F body or the else body? Okay, Grace is saying to the else body. Great. So if they're equal, if S0 is equal to S1, I'm going to go to the else. At least the name should be else. And let's see what I have in else. Here's what I have in else. And guess what? We don't have the, by the way, we can do this. So you can have else like this, and then the lines after that having the instructions. That's perfectly fine. I'm just doing that because it'll be more aligned. These two would be aligned. The indentation doesn't mean anything in MIPS. So indenting is just to kind of make it more readable. So here, I think Grace, you probably meant to do this. You meant to do this. Yeah. So this is the else. So this one is going to be this. And of course, it would be add, not add immediate. And here it would be add. And this line, adding S1 to S1 and putting it in S1 is this one. So that's good. So this is great. And let's look at the after, make sure the after is correct. So here we're adding 20 to S0 to kind of 0 and putting it in S0. That's correct. Oh, no, here we're adding 20 to S0. So you have to put S0. But you know what? I apologize. This example was long, unnecessarily long. I should have made it kind of more compact. I should have done maybe just a single line. I wanted it to be a little different than here, and I figured maybe we can do 2 lines, but that made it, kind of longer. Okay, so let's kind of do the else. So the else looks like this. So this is exactly how we have in C. Let's look at the after. The after looks actually like this. This is correct. Of course, this one would be S1. Let's look at the else and after. Do you have any questions about this? Does that look right? Give me a thumbs up if this looks right. Okay, yeah, this looks right. This should be right. So this is good. So if they're equal, I want to go to the else. I do the else, and I do the after, and that's actually great. That's perfect. Now, of course, if they're not equal, or excuse me, let me take this back. If they're not equal, because here we're saying if they're equal, go to the else. If they're not equal, which means that if they are not equal, it's really the same thing here, which means really it's that we're going to go to the if. So we go sequentially. So this if label is not necessary. We can just go sequentially. And we're going to hopefully do the if. So let's see. This one is actually not the if. We need to fix it. And this one is not, but we can make it, we can fix it. So these 2 lines right now correspond to these 2 lines. And after that, of course, I want to make sure that I skip the else, because when you do the if body, you skip the else. And because of that, we have a jump to after, which is perfect. But this one is really not necessary. I mean, this line is not, we're never going to see this line. This line is not going to execute, because if we go sequentially, we're going to go to after. If we go to else, clearly we're going to skip this one. So this one is really not needed. So let me pause here. I want you to look at this, make sure that this makes sense before we go to the next topic. All right, so the question is, instead of doing jump after, can we do branch on equals 0, 0 after? You can do that, but really you don't want to do this. I mean, this one again might be misleading. It's gonna work, but people are gonna maybe think, why did you do this? I mean, they might. It's kind of this doing the same thing, but using kind of more characters. So it would be weird to do this. If you want to jump to after, unconditionally, then you want to do J. And J is a command. J is actually a better command than branch on equal. It's better for reasons that I'm not going to mention right now, but it is a better command than branch on equal. It's actually a very different command. So when we talk about the categories of commands, you will see that branch on equal belongs to a different category than the jump. And the jump has an advantage that branch on equal doesn't have. But we'll leave that until we get to that point. But the answer to your question is yes, we can do that, but we really wouldn't want to do that. We want to do jump. All right. So I'm gonna stop the recording, and we have 20 minutes left. I'm gonna start talking about the other instruction, and then we'll do examples for that instruction tomorrow, and then we'll start with the loops. So let me stop recording.